Want to show you how to calculate the entropy change for a mixing problem. Two tanks A and B are separated by a partition. At the initial state, tank A contains 2 kg of steam at 1 megapascal, 300 degrees C, while tank B contains 3 kg of saturated mixture at 150 degrees C with a quality of 0.5. Now that the partition is removed, and the two sides are allowed to mix until the mechanical and thermal equilibrium are established, and the final pressure is 300 kilopascal. Determine A, the temperature and quality of the steam. At the final state. B, the amount of heat loss from the tanks. C, if the surrounding is at 20 degrees C, what are the entropy changes in the system and its surrounding? D, does this process violate the increase of entropy principle? Apply consistent problem-solving procedures. Identify system, process, and substance. Fill the table. Find work. Apply corresponding first law. Apply corresponding second law. The system is a closed system. Substance is water. This is a mixing problem, and there's no boundary work. Step 1. As fill the table. Note an extra column is added to account for entropy. The control volume consists of both tanks so that the system is closed. As a result, mass in the volume at state 2 is equal to the sum of tank A and tank B at state 1. We were given intensive properties at both tanks, so we can find everything on the table for both tanks. For state 2 now, since we know mass and volume, we can find specific volume. With the pressure given as 300 kilopascal and specific volume, we now find everything in state 2. This is a mixing problem. There's no boundary work. Apply the first law. Substituting in all the numbers from the table below us, we can find the total heat transfer to be negative 3968.6 kilojoule. This number represents the total heat transfer for the system. Let's now apply the second law. We can very simply find the change of entropy of the system by subtracting the entropies of the initial and the final states from each other. The change of entropy of the surrounding can be found by the equation negative Q system divided by temperature of the surrounding. Note, we know the Q of the system from the prior slide. And the temperature of the surrounding was given to us at 20 degrees C. Substitute in these two numbers and we can get the entropy change of the system. Make sure, entropy change of the surrounding, Make sure the temperature you use for the surrounding is in Kelvin. According to the increase of entropy principle, entropy of the universe must increase all the time for an irreversible system. The fact that the summation of these two entropies is a positive number indicates that this particular system does not violate the second law.